Welcome to this video on materials chemistry, synthesis and properties. In this video, we will explore the fascinating world of materials chemistry, which is the study of the synthesis, structure, properties, and applications of materials. Materials chemistry is a multidisciplinary field that combines principles from chemistry, physics, engineering, and materials science. It involves the design and synthesis of new materials with specific properties and functions, as well as the characterization and understanding of their structure and behavior. Materials chemistry plays a crucial role in many areas of modern technology, such as electronics, energy, medicine, and transportation. By developing new materials with improved properties, we can create more efficient and sustainable devices and systems. In this video, we will focus on the synthesis and properties of materials, which are two key aspects of materials chemistry. We will explore how materials are synthesized, what factors influence their properties, and how we can use this knowledge to design new materials with specific functions. So, let's dive into the exciting world of materials chemistry and discover the secrets of how materials are made and how they behave. In materials chemistry, the synthesis of materials refers to the process of creating new materials from raw materials or existing compounds. The synthesis process can involve a wide range of techniques, such as chemical reactions, physical methods, and biological processes. Chemical synthesis is one of the most common methods used in materials chemistry. It involves the reaction of two or more chemicals to form a new compound with specific properties. Chemical synthesis can be carried out using various techniques, such as solution phase synthesis, solid-state synthesis, and vapor phase synthesis. Solution phase synthesis involves dissolving the reactants in a solvent and allowing them to react to form the desired product. This method is widely used for the synthesis of organic and inorganic compounds, such as polymers, nanoparticles, and metal complexes. Solid-state synthesis involves mixing the reactants in a solid state and heating them to promote the reaction. This method is commonly used for the synthesis of ceramics, semiconductors, and other materials that require high temperatures and pressures. Vapor phase synthesis involves the reaction of gases or vapors to form solid or liquid materials. This method is commonly used for the synthesis of thin films, coatings, and nanoparticles. In addition to chemical synthesis, materials can also be synthesized using physical methods, such as deposition, sputtering, and lithography. These methods involve the deposition of materials onto a substrate using various techniques such as thermal evaporation, plasma deposition, and photolithography. Biological processes, such as biomineralization and biomimicry, can also be used to synthesize materials. Biomineralization involves the formation of minerals by living organisms, while biomimicry involves the synthesis of materials that mimic the properties of biological materials, such as bone and shell. Overall, the synthesis of materials is a complex and multidisciplinary process that requires a deep understanding of chemistry, physics, and materials science. By developing new synthesis techniques and optimizing existing ones, we can create new materials with unique properties and functions. The properties of materials are the physical and chemical characteristics that determine their behavior and functionality. The properties of materials can be classified into several categories, such as mechanical, electrical, optical, magnetic, and thermal properties. Mechanical properties refer to the behavior of materials under stress, such as strength, stiffness, and toughness. These properties are important for designing materials that can withstand mechanical loads and deformations, such as in structural materials and biomaterials. Electrical properties refer to the behavior of materials under the influence of electric fields, such as conductivity, resistivity, and dielectric constant. These properties are important for designing materials that can conduct or insulate electricity, such as in electronic devices and energy storage systems. Optical properties refer to the behavior of materials under the influence of light, such as absorption, reflection, and refraction. These properties are important for designing materials that can manipulate light, such as in optical fibers and lenses. Magnetic properties refer to the behavior of materials under the influence of magnetic fields, such as magnetization, susceptibility, and coercivity. These properties are important for designing materials that can store and manipulate magnetic information, such as in magnetic storage devices and sensors. Thermal properties refer to the behavior of materials under the influence of heat, such as thermal conductivity, specific heat, and coefficient of thermal expansion. These properties are important for designing materials that can conduct or insulate heat, such as in thermal management systems and thermoelectric devices. The properties of materials are determined by their composition, structure, and processing history. By understanding the relationship between these factors and the properties of materials, we can design new materials with specific properties and functions. In the next segment, we will explore how the synthesis and processing of materials can be used to control their properties and functionality. In materials chemistry, the processing of materials refers to the various techniques used to modify the structure and properties of materials after they have been synthesized. Processing can involve a wide range of techniques such as heat treatment, mechanical deformation, and surface modification. Heat treatment is one of the most common processing techniques used in materials chemistry. It involves heating the material to a specific temperature and holding it for a certain amount of time to induce structural changes. Heat treatment can be used to improve the mechanical, electrical, and thermal properties of materials, as well as to control their microstructure and phase composition. Mechanical deformation is another processing technique used to modify the properties of materials. It involves applying mechanical stress to the material, such as through rolling, forging, or extrusion. Mechanical deformation can be used to improve the strength, ductility, and toughness of materials, as well as to control their grain size and texture. Surface modification is a processing technique used to modify the surface properties of materials. It involves the deposition of a thin layer of material onto the surface of the material, such as through chemical vapor deposition or physical vapor deposition. Surface modification can be used to improve the adhesion, workability, and biocompatibility of materials, as well as to control their surface roughness and chemical composition. In addition to these techniques, there are many other processing techniques used in materials chemistry, such as electrochemical processing, pulsar processing, and laser processing. Each of these techniques has its own advantages and limitations, and the choice of processing technique depends on the specific properties and functions required for the material. By using processing techniques to modify the structure and properties of materials, we can create new materials with improved performance and functionality. In the next segment, we will explore some of the applications of materials chemistry in various fields, such as energy, electronics, and medicine. Materials chemistry has a wide range of applications in various fields, such as energy, electronics, medicine, and transportation. By developing new materials with improved properties and functionality, we can create more efficient and sustainable devices and systems. In the field of energy, materials chemistry plays a crucial role in the development of renewable energy technologies, such as solar cells, fuel cells, and batteries. By designing new materials with improved conductivity, stability, and efficiency, we can create more effective and affordable energy storage and conversion devices. In the field of electronics, materials chemistry is essential for the development of new electronic devices, such as transistors, LEDs, and sensors. By designing new materials with improved conductivity, transparency, and stability, we can create more advanced and versatile electronic devices. In the field of medicine, materials chemistry is used to develop new biomaterials for tissue engineering, drug delivery, and medical imaging. By designing new materials with improved biocompatibility, biodegradability, and functionality, we can create more effective and safe medical devices and therapies. In the field of transportation, materials chemistry is used to develop new materials for lightweight and high-strength components, such as in aircraft, automobiles, and ships. By designing new materials with improved strength, durability, and corrosion resistance, we can create more efficient and sustainable transportation systems. Overall, materials chemistry is a rapidly growing field with numerous applications and opportunities for innovation. By continuing to explore the synthesis, properties, and applications of materials, we can create new materials with unprecedented properties and functions, and contribute to the advancement of science and technology.